Hello everyone, welcome back to online Sabi video tutorial on hydrology and irrigation engineering. In this class, we are discussing what is irrigation efficiency and what are the types of irrigation efficiencies. So in general, we know efficiency is the ratio of output to input. So here as we are discussing the irrigation efficiency, so which is denoted with the symbol eta, so which is water output to the water input. Okay, so that is the general definition of efficiency. So but what is irrigation efficiency? See, the ratio of water utilized to the water supplied is termed as irrigation efficiency. So water utilized will be your output and water supplied will be your input. Okay, so the ratio of water utilized to the water supplied is termed as irrigation efficiency, and the efficiency is expressed in terms of percentages, as you know. And what is the objective of this efficiency, by the way? See, the object of this efficiency so is to show when improvements can be made which will result in a more efficient irrigation. So where, in which place you have to improve the irrigation. Okay, so where that will give you the good result. Okay, so that is the objective of the irrigation efficiency. So we have different types of efficiencies, like we have water conveyance efficiency, water application, water use, water storage, water distribution, and consumptive use of efficiency. So these are the different types of efficiencies we have. Let us discuss one by one what is the water conveyance efficiency. The first type of efficiency is the water conveyance efficiency, so which is denoted with the symbol eta C. So it is the ratio of water delivered to the field from the outlet point of the channel to the water pumped in the channel at the starting point. So which is nothing but water delivered means that is the output. Okay, and water pumped into the channel, that is your input. Okay, so like for example, if you take this is the source, so from this source you are withdrawing water and you're supplying to the agricultural field. So this is the source and this is the field. So you have a channel here. So it is the ratio of water delivered here, water delivered to the field to the water pumped in the channel at the start. See, this is the starting point of the channel. So water pumped at the starting point into the channel, okay, and water delivered. So it is the ratio of water conveyance efficiency. So is the ratio of water delivered to the field, okay, from the outlet points. This is the outlet point. From the outlet point of the channel, so to the water pumped into the channel at the starting point. So this is the starting point and this is the outlet point. So that is nothing but water conveyance efficiency. So here this water conveyance efficiency so considers the conveyance or a transit losses, because see, the water is carried through the channel. Obviously when it is passed on through the channel, there will be a conveyance losses. So this efficiency will take into account the conveyance losses, and you have an expression to determine this conveyance efficiency, that is eta C is equal to WF divided by WR into 100, where eta C is your water conveyance efficiency and WF, so WF is the water delivered to the field, okay, or irrigation plot, okay, and WR is the water supplied or diverted from the river, that is at the starting point. So water delivered to the field to the water supplied to the channel, WF and WR. So that is the water conveyance efficiency. So the second type of efficiency, you have the water application efficiency, which is denoted with the symbol eta alpha. So what is this water conveyance efficiency then? It is the ratio of quantity of water stored in the root zone of crops to the quantity of water delivered actually into the field. Okay, so water application efficiency means, so it is the ratio of water stored. For example, if you consider this is agricultural field, you have a crop here. Okay, so you are supplying some quantity of water. Okay, like just assume it as Q. Okay, and in that Q amount of water, whatever the quantity of water stored by the root zone, okay, whatever the quantity of water which is stored by the root zone, so that is water application efficiency. Okay, the ratio of water stored in the root zone to the quantity of water delivered to the agricultural field is called the water application efficiency. Because so what, for example, if you are supplying 1 cubic or 2 cubic of water, so in that 2 cubic, just consider 2 cubic, in that, so the root zone can extract only 1 cubic, it can store only 1 cubic. So the ratio of 1 to 2 is your water application efficiency, that is nothing but 50%. So that is the water application efficiency. So it is also called as a farm efficiency. And here, so this will take the account of water loss, like it may be evaporation loss, because so in this 2 cubic, only 1 cubic will be stored. Okay, so it is the water stored to the water delivered. So what happened about remaining 1 cubic? It may be a loss. So it will consider the loss occurred in the field. That is, it may be evaporation loss or runoff loss, any other losses. So that is your water application efficiency, and it is denoted with the symbol eta alpha, and it is calculated using the formula eta alpha is equal to Ws divided by Wf into 100. So Ws is the water stored in the root zone. Okay, and Wf is the water delivered to the farm. That is your water application efficiency. And here, see, this water application efficiency mainly give a focus, mainly focuses on the suitability of method of application of water. For example, see, the name itself says it is water application efficiency. So basically, so this depends upon the method of application. Okay, whether you're doing a flooding method, so based on that method of application of water, this efficiency will vary. And also, so the losses, as it is considered the losses, the common losses which are considered are, one is the surface runoff and the deep percolation. So only those two losses are considered in the water application efficiency. As I have already told, for example, if you're supplying 2 cubic, okay, you just assume you're supplying 2 cubic. So in that only 1 cubic is stored by the root zone. So remaining 1 cubic, it may be lost as in runoff, or it may be lost as in deep percolation. Okay. So that like Wf, which is nothing but the amount of water stored in the root zone, will be equal to Ws plus Rf plus Df. Clear? So from this Wf, that is nothing but, so Wf is the water supplied to the field. Okay, so Ws is the water stored in the root zone. So according to this losses, so whatever the total quantity of water you're going to supply, that is, Wf is the total quantity of water you supply to the field. So it includes water stored in the root zone plus the losses, storage plus losses. The losses are Rf plus Df. So from this, you can rewrite Ws is equal to Wf, okay, Wf minus of Rf plus Df. So you can rearrange the equation. So that is, if you see here, so eta alpha, that is water application efficiency, is what? Ws by Wf into 100. So Ws is the water stored in root zone to the water supplied to the farm. Okay, so Ws will be equal to what? Wf minus of Rf plus Df. So eta alpha will be equal to what? Wf minus of Rf plus Df divided by Wf into 100. So this is the equation for water application efficiency. And this eta alpha, that is nothing but the water application efficiency, should be at least 60%. So that is for all well-designed surface irrigation system. So for all the surface irrigation system, so the eta alpha should be at least 60%. Okay, so for example, for a sprinkler irrigation, so this water application efficiency should be 75%. And there are some factors which reduces this water application efficiency, that is irregular land surfaces and shallow soils underlined by gravels, okay, of light permeability, and either a very small or excessively large irrigation streams. All those will reduce the value of eta alpha. So, and also non-attendance of water during irrigation, long irrigation runs, wrong irrigation methods, and improper preparation of land before cultivation, and compact impervious soil, steep slopes, excessive single application. So all these factors will reduce the value of water application efficiency. So the third type of efficiency we have, that is water use efficiency, which is denoted with the symbol eta U. So it is the ratio of water beneficially used, including the leaching of water, to quantify to the quantity of water delivered. Okay, so whatever it is the ratio of water beneficially used, water used to the water supply, that is water use efficiency, which is given by eta U is equal to WU divided by WD into 100. So where WU is the water used efficiently or beneficially, and water WD represent water delivered. So WD is water delivered, WU is water used beneficially or sufficiently. And the fourth type of efficiency is water storage efficiency, which is denoted with the symbol eta S. So here the water storage efficiency will give information like how to store the required quantity of water in the root zone completely during irrigation. As I have already mentioned, in case of water application efficiency, for example, if you are supplying 2 cubic of water to the agricultural field, so then the root zone, whatever the plant roots will be there, so it can store, due to the losses, it will store only 1 cubic. So the concept of this water storage efficiency will give you how to store this complete 2 cubic of water in the root zone. So that the concept, the information how to store the required quantity or the complete amount of water in the root zone during irrigation will be given by this water storage efficiency. So here it is defined as the ratio of water stored in the root zone during irrigation, so to the water needed in the root prior to the irrigation. For example, if you have grown some crops, it requires around 3 cubic of water. Okay, it requires 3 cubic of water. Okay, but so that is before irrigation. So water needed was 3 cubic. Okay, so but water stored is how much? It is only 2 cubic. So the ratio of 2 by 3, that is water stored in the root zone during irrigation to the water needed in the root zone before irrigation, is called the water storage efficiency. So that is prior to the irrigation means that is your field capacity. So which is given by eta S is equal to WS divided by WN into 100, where WS is the water stored in the root zone, that is during irrigation, and WN is the water needed. Okay, water needed in the root zone before irrigation. Prior means before irrigation. So that is equal to field capacity minus the available moisture content. You will get the water needed. Water needed will be field capacity minus available moisture content. So the next type of efficiency is water distribution efficiency, which is denoted with the symbol eta D. So this efficiency evaluates degree to which water is uniformly distributed throughout the root zone. So when you're supplying, so all the crop root zone should get water uniformly. So water distribution, the water should distribute so throughout the agricultural field uniformly. So that uniform distribution of water throughout the root zone is given by this water distribution efficiency. And uneven distribution so will give you a improper results. It won't give a desirable results. It will give you undesirable results. So, and this water distribution efficiency is calculated using eta D is equal to 100 into 1 minus y by d. So, where eta D is water distribution efficiency, and y is the average numerical deviation. Okay, in the depth of water stored from average depth stored during irrigation. So it is nothing but the average depth stored during irrigation to the depth of water. So the deviation. So there will be changes in the depth of water supplied to the depth of water stored. And D is the average depth of water stored during the irrigation. So that is water distribution efficiency. And also, so the more uniformly the water is distributed, the better will be the crop response. So if the water is uniformly distributed throughout the agricultural field, so it will give you a good response from the crop. And also this efficiency, so will provide the measure, like it will give you the comparison of methods of water application. So which method gives a uniform distribution of water, whether that is comparison of sprinkler with the surface and one sprinkler with the other sprinkler, okay, one surface method to other surface method. So like that it will give you this particular efficiency, will give you the comparison between the method of application of water. And the last type of efficiency is the consumptive use efficiency, which is denoted with the symbol so eta Cu. So where eta Cu is WCU divided by WD. So where WCU, which is also denoted as Cu, which is nothing but the normal consumptive use of water. And WD is the net quantity of water depleted from the root zone. And here, see, this consumptive use of efficiency evaluates the loss of water by depopulation and by excessive surface evaporation. So because see here, the WD is the net amount of water depleted from the root zone. So from the root zone, how much amount of water so have gone beyond the root zone through the depopulation. So it will give you the information regarding the loss of water by a depopulation and surface evaporation. Thank you all. In the next class, we'll see the next topic.